Let's talk a little deeper about the intermediate value theorem. So I gave you the big calculus mathy definition that if a function is continuous on an interval a to b, and k is some value in between f of a and f of b, then there's at least one x value c between a and b such that f of c equals k. What? All right, I'm going to show you something that might help a little bit. Okay, so the idea is when 2 points are connected by a continuous curve, okay, here's a continuous curve, and when 2 points connect those two curves, to get from one point below a line to another point above the line, you have to cross through the line. That's all the intermediate value theorem says, that if I have some point A below a line and another point B above a line, that to get from A to B, I have to cross that line. And oftentimes what we'll say is, I know what this line is, so say this line is some number, then we have to find what x value gives us that point. And it makes sense, right? It actually really makes a lot of sense. So one of the conditions, remember, is that the curve has to be continuous. So there can't be any gaps or jumps in the curve for it to for the intermediate value theorem to work, which makes absolute sense, right? Because if it's not continuous, it's not guaranteed to go through every single point. But if it's continuous, we absolutely have to go through every single y value to get there, right? And remember, continuous just means that we are drawing it without lifting our pen. So back to our formal definition, if a curve is continuous on the interval a to b, then there is guaranteed to be a number, I guess actually I shouldn't say that, and there is a y value in between the y value of a and the y value of b. We are guaranteeing that there is an x value that produces that y value. Okay? So let's go back to the notes. And we'll check this one. So the question is, does the intermediate value theorem guarantee a c value on this interval? So we're saying here's a function. Does the intermediate value theorem guarantee that there is some value that equals 4 on the interval 0 to 3? So the first thing that we need to check is f continuous for this interval? Remember, that's number 1. Or g of x. Is g of x continuous on the interval 0 to 3? Well, there's a discontinuity at 2 because 2 would make us divide by 0. Therefore, g of x is not continuous on the interval 0 to 3. Therefore, the intermediate value theorem does not apply. And that's it. That's the whole thing. If a function does not guarantee or does not satisfy all of these requirements by the intermediate value theorem, then it does not guarantee anything. We just can't even use the intermediate value theorem. So remember, the things that you have to check when you're doing the intermediate value theorem, you absolutely have to check, is the function continuous on the stated interval? Second, you have to check if the k value that you're looking for, or we can say this y value that we're looking for, is in between the y value of a and the y value of b. Okay? If we're looking for some number up here, the intermediate value theorem doesn't guarantee that the function does a loop-de-loop up and back down, right? So if those two conditions are met, then we guarantee that there is some x value where this function crosses the line k. And again, it's super important because this helps us see where there are zeros. So if k equals 0, and I say, all right, this function is continuous from 5 to 7, and f of 5 is -2, and f of 7 is +8, to get from -2 to +8, I have to cross over this line, right? To get from here to here, I have to cross over that line. So it guarantees that there is a number somewhere on the interval that crosses that line, and then oftentimes, like we did before, we'll find that value by finding what x value produces the y value that we're looking for. So there you go. That is the intermediate value theorem in a nutshell.